Hi, I just want to show you one more example of the sessions 8.4. Okay, so let's look at this picture. Let's say if we want to find the shortest path from A to C. Okay, so you see what I did is I print screen a lot of pictures of the graph, and then I separate into steps, different steps. I have a different graph and to illustrate you. But right now, what happens if you only have one graph and you want to write everything down on this graph? Okay, this is what we do. You can still label the steps. First step, we label LA is 0. Okay, and all the rest is infinity. Then if it's infinity, you don't need to write it down because it will mess up our graph if we only have one graph. Okay, so LA is 0. That is the first steps. And then you look at what are the vertices that are adjacent to A. Well, in this case, we have S, B, and T, right? So S, B, and T. Okay, and then we figure out what is LS, LB, and LT. Alright, so LS is 7, LB is 1, LT is 6. So far, so good. And then which one is the minimum? Well, this guy is the minimum, right? So LB is minimum. We circle B. Okay, circle B. And this is, the label is 1. This is 7. This is 6. Okay, circle B and figure out what are the vertices that are adjacent to B. Adjacent to B and uncircled vertices, it can be S, it could be D, right? And that's it. So LS, LD, because we already have LS before, so now it's gonna be the minimum of 7. And what's the new one? So we have 1 plus 4. Oh, now the minimum is 5. LD, D is the label of B1 plus 3, which is 4. Okay, so now see, I changed this guy to 5. So you can cross out the 7 and put a 5 there. And DD, the label is 4. Okay, so I'm drawing all the steps into one graph. I think this is usually what you do because you don't have a word, you don't have time like in the exam to draw many graphs on your paper. Okay, so what's next? Okay, you see what are here are the vertices with the uncircled vertices. Okay, which one is the minimum? Well, the D is the minimum, right? So we can do step 3. D is minimum. So LD is minimum. We can circle the D. Okay, so circle the D. Now, what are the vertices that are adjacent to D? We have S again because it's uncircled, so we still need to include it. We have C and we have T. So L, S, L, C, and L, T. Well, S is minimum of what we had before, 5. And now if it's passed through D, D is 4. And the edge between them has weight 9. Okay, the minimum is still 5. C is now 4 plus 1, which is 5. Okay, and T, we have T before, so that is minimum of 6. And when we pass through D, so 4 plus 3 is still 6. Okay, so we have, this is 5, and that's still 6, and that's 5. Okay, now the 4 sets, what are the minimum? Minimum is the 5, so that's LS and LC. And we circle them. And that's great because we are done. because we circle the C and C is our goal. Okay, so we can end. Our C is 5. What is the shortest path? Well, the shortest path is, okay, how do you use, you have C, you go back. How do you get your C from the D, right? How do you get to your D from B? How do you get to B from A? So far, so good. So this is how you write your solution in your homework or exam. You don't need to draw the graph many times, but please list all the steps so that I can follow your work. In order to get all the credits, you need to show all your work. Okay, you cannot just give me a shortest path. You have to show all your work. Okay. So and that's it for this example. Do you want to do more example? Okay. Do you want to do some example like here or there? Okay, which one do we want to pick? How about this guy? Okay. Let me create more space here because I really want to show you more examples. All right, let me, okay, can I move this one here? Oh, okay. And I can move to the left so that I can have more space. All right. Oh, and this guy, I moved to the next page. Okay. All right. Okay, so pick any two vertices that you want to go from which to which. What do you want? How about from S to C? Okay, how about from S to C? Okay, so the first step, LS is 0. Okay, circle it. Oops, it looks like it's already circled, but I hope you can see my color, my color orange. Okay, and then we find, so we find the vertices that are adjacent to S. We have A and F. Okay, so A and F, then L of A, L of F, L of A is, so if the graph is not so complicated, I don't write the vertices as the label. But if the graph is more and more complicated, then I would like to include the vertices in the label. Then it's easier for me to check, okay, where is the label comes from, which vertex. Okay, but in this case, I would say this graph is still not quite complicated. So I will I won't write the vertex in the label, but you can do whatever you like. Okay. So LA is 7, LF is 4. So this is 7, this is 4. Okay, then which one is the minimum? The minimum is L of F. Then circle F. Okay, then we want to find the vertices that are adjacent to F. Well, this is E and G, right? E and G. And then we have LE and LG. So LE is from F, which is labeled as 4, and then plus 11. It gives us 15. And G is 4 plus 9, that is 13. Okay, now you compare. Wow, you compare which one is the smallest? LA, right? So circle A. Okay, circle A. What are the points that are adjacent to A? we have B and E. Okay, so don't forget to include the E, even though we already have a label for E, but it's not permanent. So L, B, L, E. LB is 7 plus 5, which is 12. LE, because it already have a label, so it's the minimum of its original label. And then we have the label of A. So 7 plus 2. Ooh, you see it changed to 9 now. So cross the 15 and change to 9. The B is 12. So far, so good, everybody. Okay, next, what is the minimum? So step 4, minimum is out of E, right? And it's 9. Okay, let's see. Then we circle the E. Okay, and what's next? What are the vertices that are adjacent to E? We have D, just D, right? So out of D is then E is 9 plus 3, which is 12. So D is 12. So far, so good, everybody. And next one, which one is the minimum? So you see, these two are 12 is smaller than 13. So minimum is LB and LD. So we circle them. Adjacent to B. You see the process repeats a lot. Adjacent to PB is C. Adjacent to D is C and G. We also need to include G because it's not circled. Okay, so LC. Okay, LC when we go from B is 12 plus 4, which is 16, and LC. So I should put this guy here. All right. Okay, yeah, I should put this guy here because this C is now we're looking at the D. So we pick minimum of what we calculated before, and look at the D. D is 12, and then the edge between them is 2. So which is 14. Ooh, this is smaller. So C is actually 14, and then LG. So LG is we already have 13 there, but now it's D plus 8. So minimum of 13 and D is 12 plus 8. Oh, the minimum is 13. Okay, so that's 13. Okay, now you see, even though we already reached the C, we get label for C, but because now it's not minimum, you still need to go, you need to continue. So the minimum is LG. So circle G. This is a good example. Okay, because it talk about what I mentioned. You, even though you have a label for the C, it could be the shortest path, but because it's not minimum among those uncircled vertices, you have to continue the process until you show that LC is minimum. Okay, so circle G. So what are the points, vertices that are adjacent to G is H. And then LH is then 13 plus 1, 14. Okay, now you can circle them. So 7, you can see the minimum is LC and LH. Now we can circle C and H. Now the process and. Okay, so process and here. LC, it is 13. Oh, sorry, 14, I mean. And what is the shortest path? Okay, so C, how do you get C? From, you see, this minimum, how do you get it from the minimum? That's because of the D. So, through the D. And how do you get to your D? You get to your D from the E, right? And how do you get your E? Your E, oh, is this guy. So this guy is from A. So far, so good, everybody. And how do you get to our A? Is from S. Okay. So, because in this process we didn't label the vertices that it is from, so when you find the shortest path, when you go back to the vertex, you have to be very careful, especially like here, LE, there are two numbers. But this number, where's this number come from? This number is come from here. So this number come from the F, but we're interested with the shorter number. So shorter number, this is 9. It comes from A. So you have to be careful to like judge which vertex it is from. So far, so good, everybody. And yeah, I want to mention again because it's so important. Even though here you already get the shortest path, but you still need to continue and show step 6 and 7 until you are able to circle it. Okay, so don't forget these steps. Okay, so even though you have a label for 13, but sorry, I mean this one, 14. Even though you have this label, but you haven't shown it is the shortest path. You have to continue until you're able to circle that vertex to show it is really the shortest path. Okay, this is a really good example. I think I hope you can play around with the graphs that I provide. You can also search online for more exercise, and you have your homework exercise as well. You can, with the same graph, you can start with G and you ask how do we get to B, etc. Okay, so practice more. Yeah, so I hope this video can show you what other steps are, even though I draw everything on the graph. So yeah, this is the bad thing, because just if you don't look at my steps, if you just look at the graph, you have no idea how I get to this point, right? So including the steps and show your work is really important. Like your homework and exams, it tell me how you think. Okay, so not only the final answer is important, the most important, I would say, is the process. All right, so have a nice day. Bye.